When you picture Mars, I bet you see that classic red planet look. Maybe even imagine it was once, flowing with water.
Right, maybe lush.
Exactly. But hold that thought. Because recent discoveries, they're really shaking up what we thought we knew about its ancient climate.
Totally rewriting the narrative.
So today, we're doing a deep dive into these, pretty radical new insights.
Yeah, the big question has always been, why is Mars this parched desert now while Earth is teeming with life?
And it feels like we're getting closer to a real answer.
Well, it looks like new findings, especially around these things called carbonate minerals, are fundamentally changing how we see Mars's past. It's definitely not what we used to think.
Okay, so our mission today, let's unpack what NASA rovers, Curiosity, Perseverance, what they're actually telling us about Mars's real climate story.
And what that means for life beyond Earth. It has huge implications.
Huge. So for years, the idea was sustained warm and wet Mars. Oceans, maybe?
That was the dominant theory, yeah. Vast oceans, rivers. But the recent rover data, it's painting a very different picture.
Different how?
It suggests those periods with liquid water were actually pretty brief, isolated moments.
So not long-lasting seas.
More like fleeting runoff,
Yeah.
or maybe just blips in the grand scheme of its geological history. For the most part, it seems Mars has been an unforgiving desert.
Wow, okay. That's a major shift from, the Mars ocean posters we all imagine.
It really is.
So if it wasn't constantly wet, what went wrong? What happened to its atmosphere?
Well, that's where these carbonates become really interesting. NASA's Curiosity rover found rocks unexpectedly rich in carbonates right there on the surface.
Carbonates, like limestone on Earth.
Exactly like that. And on Earth, those rocks are crucial, right? They trap atmospheric cuduros. They help moderate our climate over millions, billions of years.
Right, they act like a CO2 sponge, locking it away.
Precisely.
How?
And Curiosity's findings suggest Mars did the same thing. It effectively locked up coheros in stone.
So it siphoned off the very gas it needed to keep a thick atmosphere, the greenhouse gas.
You got it. It basically sucked away the ingredient needed to keep the planet warm enough for stable liquid water. Mars, in a way, sealed its own fate.
Okay, that makes sense for losing the atmosphere, but Earth does that too, right? Locking up CO2.
It does.
But we have active volcanism. Volcanoes constantly pump CO2 back into the air, kind of balancing the books and keeping our greenhouse effect stable. Did Mars just not have that?
That seems to be a key part of the story. Mars's volcanic activity appears to have been too, feeble.
Feeble?
Yeah, not strong or consistent enough to replenish the CO2 that was getting locked into those carbonate rocks, so the whole climate cycle got thrown out of whack.
Like trying to fill a leaky bucket with a dripping tap.
That's a great analogy. The water level, the atmospheric pressure and temperature just kept dropping.
And the result?
The result was that those early periods, which clearly had some big floods, carving valleys, they gave way to these incredibly long dry spells. We're talking roughly 100 million year dry spells.
Yeah. 100 million years. Wow.
Yeah. Far, far too long and too dry for life as we know it to really get established and thrive, you'd think.
Okay, so forget planet-wide seas. We're looking at, puddles?
Maybe a bit more than puddles sometimes, but certainly not global oceans. More like fleeting habitable oases.
That really changes the mental image. How does this affect the search for Martian life, then, if the water was so temporary?
Well, there's modeling work published in Nature, actually, led by Edwin Kite. It supports this idea. The combination of carbonate formation sucking CO2 out and limited volcanic gas putting it back in.
It just leads to sporadic wet spots?
Exactly. Sporadic oases of habitability. Think isolated springs, maybe, or short-lived lakes, rather than anything planet-wide and persistent.
So the crucial question becomes, could anything survive that? Could microbes hang on through those 100-million-year dry spells?
That's a multi-billion-dollar question, isn't it? It makes finding evidence of past life potentially harder if it was restricted to these little transient pockets.
But maybe water is still there, just not on the surface. Could it be underground?
That's definitely a possibility and a focus for future missions. Liquid water might still lurk deep underground.
Protected somehow?
Yeah, maybe kept liquid by geothermal heat or perhaps in residual aquifers deep down, shielded from the harsh surface.
Any hints of that?
Well, Perseverance has detected carbonate deposits right at the edges of where an ancient lake once was. That hints the chemistry might have been right for life, at least temporarily.
So the ingredients were there? Possibly.
Possibly. Yeah. But the ultimate test, really, is getting rocks back here to Earth.
Sample return?
Exactly. Both NASA and China have plans for that in the next decade or so. bringing Martian rock samples, especially those carbonate-bearing ones, back to labs here.
To see if they're sterile or...
Or if they hold fossilized microbes. That would be, well, revolutionary.
Absolutely. So let's wrap this up. These insights, the carbonates acting like a CO2 sponge, the weak volcanism failing to keep up, the water being just fleeting, it completely reshapes our view of Mars's past.
It really does.
And it makes you wonder, how does this change your understanding of how easily life might start on rocky planets generally?
That's the big takeaway,
Yeah.
especially now we know of, nearly 6,000 exoplanets out there. Mars is our closest case study.
So what are the implications?
Well, there's sort of two profound possibilities branching out from this. If Mars, despite having liquid water briefly, never actually hosted life, does that mean life's origin is incredibly difficult? A really rare cosmic fluke?
A sobering thought.
But conversely, if we do find evidence, even just microscopic fossils in those returned samples, does that suggest life pops up pretty readily, wherever the conditions are, even briefly right?
Two very different universes, really.
Absolutely. So the question Mars might ultimately answer for us is, which path is it? Are we likely alone, or is life common? What will Mars tell us about those cosmic odds?